So for number one, it's saying a particle moving under a conservative force oscillates between x1 to x2. Show that the period of oscillation, that tile t, that period, tile t, period t of oscillation is given by 2 integral of x1 to x2 square root of m over 2 v of x2 minus v of x dx. In particular, if v is given by half omega naught squared s squared minus bx to the power 4, show that the period for the oscillations of amplitude A is given by that. So oscillations of amplitude A, it will be given by that. So that's what we want to show in that part. Number one. All right, show the general form period. So for a particle of a mass m moving in one dimension under a conservative force. So by conservative force, we mean that that force is equals to the negative of the potential, which means the total energy. And remember, this one is moving in one dimension. It's one dimension under a conservative force. It's not in two dimensions, one dimension. So that V prime of X, total energy. So the E, the total energy E. So if it's a conservative force, what do we mean? For a conservative force, we mean that if F of X is equals to V prime of X, which is the potential energy, the derivative, can you see the prime there? Hello?
Yes.
Yes, that is when it's a conservative force, which means the force will be equals to the negative of that derivative of the potential energy. Only if the particle is moving and the force is conservative. That is the definition of conservative force. Then the total energy is always kinetic plus what? Potential. So this is your EK, which is your kinetic energy. And then this is your EP, which is your potential energy, which is EP. And when you're talking of Lagrangian equations, this will be T plus U. Potential, it's always U. T plus U. All right. So if I differentiate with respect to x dot, what do I get there? We are differentiating x with respect to x dot. So x dot will be equals to what? If you want to make x dot subject of the formula from the information that you are having here. First you move, E goes to the left. I mean V goes to the left, then it will be E minus V of X is equals to half M V squared. So half the M V squared, that is the X dot squared. Any question? Then you multiply both sides by 2 over M. You multiply both sides by 2 over M. Then you get X dot squared. So if I want to be left, so first I multiply both sides by 2 over M. Left and right. So which means 2 over M. Sorry. The M is on the numerator. 2 is on the denominator. I want to remove it, so it's 2 over M. So you remove it from the left by multiplying both sides by 2 over M. Then you put your bracket to be E minus V of X. what is it equals to? Equals to x dot squared. It's equals to x dot new square. So if you don't want the square, how do you remove this square? By square rooting this side, isn't it? So that's where you start your equation. First, you start by giving us the definition of potential energy, of a conservative force. Then from there, what does total energy mean? From there, make your x dot subject of the formula. From there, you differentiate, which means this x dot, in other words, what do you mean by x dot? It's dx dt, dx dt. That's what we mean. So if you want to make dt subject of the formula, so which means you are dividing everything by 1 over square root. If you want to make dt and dx on the other side. What we did here, dx dt is equals to this. What is under the square root? That is dx dt. So if I want dt, which means it's 1 over what is under the square root sign. And if it's a fraction, it changes as well. If it was 2 over m, if you say 1 over, if you want dt, then it will be dt is equals to root of m over 2 to be inverse. And the square root, it was a numerator. Now it becomes the denominator. That's what is happening. So in other words, if you want to find dt, in other words, dt is just like this. Dt is just square root 1 over square root 1 over square root. Instead of 2 over m, here you put your 2 over m bracket e minus v of x bracket, then times dx times dx, like that. So here they just rewrite to make that denominator 2 over m. If it comes on the numerator, it's the square root of m over 2. Just a manipulation. If it's on the denominator, exponents. But everything is down. Then the period of moving the particle there from x1 to x2 t, which means we are integrating from x1 to x2 of, have been given, now it's a definite integral. What did you do to the constants? Constants, it's m over 2. You take it out of the bracket. So dt, take it out of the bracket. So m over 2 outside the bracket is a constant. E over that. So that time which you are looking for, the time, for the period. So we are having 2 multiplied by square root of m over 2 from x1 to x2 dx over e minus v of x, which is this one. Any question? Any question? We are quiet. I'm saying from here we just introduced the limits in terms of dx. If you want the time taken, you introduce integral here, you get time. Then you integrate this side, you also get the x values there after you integrate. So if I integrate the left, I'm going to get t, which is the time t, which I'm looking for, the period, this one. If I integrate the left with respect to t, then if I integrate the right, which was under the square root, so the integral, then it's root of m over 2 outside the integral from integral of x1 to x2. Are you still there?
Yeah.
It's next.
No, it's still fine. I was just listening.
Mhm. So you integrate the left to get dt integral of the right dx. So t12, which means for you to move the particle from, you are moving this particle or the force between x1, x2. So those are the two conditions. Show that the period of oscillation, moving the particle between x1 and x2. So if you are moving the particle between x1 and x2, the period, check, your initial point is x1 and your x2 is so the time taken for one oscillation, check, x1 to x2. So to and from. So which means we are going back and forth. So this is forth, we are going to the front. Then this is the what? The back, from where you started, isn't it? That's a period. To complete one cycle. One cycle is now to and from. It becomes a what? A cycle. That's where this two is coming from. This two, which is outside here. It's coming from that period to indicate the period. If in terms of the period, if it's period, it means it's twice the time of going and coming back to make a complete cycle. This is x1, that is x2. So to and from. To and from becomes a period. And then what happens? What happens? The two which is outside, if I want to put it inside the square root, what is it going to become? That two which is outside there. If I want to put it to remove it from outside that two, I put it inside the square root, then it becomes a 4 inside. Do you agree?
So that too is for a complete cycle.
Yes, the two is for the period, to and from. For the period, to and from. To complete the cycle, it means you are doubling the time. The time to go and the time to come back is equal. So you double the time. Is that correct? Is that, yeah. Mm. So I'm saying that 2, which is outside the square root sign, if I want to put it inside the square root sign, it becomes what?
It's
What is
gonna be
square root of 4?
is 2.
It's simply the same thing. If I don't want it outside that 2, I can put it inside the square root sign. Then it becomes, instead of m over 2, it becomes 4m over what? Becomes 4m over 2.
Is it 4M or 2M?
4m over 2. If I put it inside, it's 4m over 2. If I remove
Oh,
it outside, to be square root of 4m over 2. Then 2 goes into 4. How many times?
2.
Yes, 2. That's why here it has been simplified to square root of 2m because we've already divided. Any question? Did you see the manipulation? So there is square root over 2m. Then the integral, we are integrating from x1 to x2 dx e. So that one we have already shown what we are required to show. The first part. So can you see the first part? Now, from there, you want to show the next part. So the one which they are referring to as V of x2, that is your kinetic energy. V of x2. The one they are referring to as V of x2 is the kinetic energy. So now we want to check the one for the second one. So this E, it's V of x2. V of x, V of x2. V of x, V of x2. V of x, potential. V of x2, kinetic. So you simply, now after you are just replacing where there is E there, you put your Vx. Just like here, under the square root. Is it fine?
Hello, sir.
I am saying this two, can you see this two which is outside? If you want to remove it there, you want to put it under the square root sign. That two which is outside, under the square root sign, it becomes what?
4.
4. And this 2 divided by 2, it becomes what?
2.
2m. So the one which I'm saying, V of x2, this is what they are referring to as E. V of x2 is what? It's your E, which is your total energy, V of x2, which is kinetic plus potential. V of x is just the potential energy. So here, once you reach this point, it's now easy to manipulate to that same format which they are having, which is equals to the integral of x1 to x2, just like that. Then you say square root. Everything is under the square root, the numerator and the denominator. Everything is under the square root. So it's square root. Square root of what? Of 2m over E minus V of x. That's what we are saying. Then if you want to take the 2 outside so that it looks the same as this one, because this one is having a 2 outside. It's having a 2 outside. So we want to make it look the same. It's just a matter of now manipulating. And look what we are having. What we are having is 2m over E minus V of x. So if I want to have a 2 outside, I manipulate. What do? I multiply the numerator and the denominator. The numerator and the denominator times what? So that it looks like this. So that it looks like this. I have 2m over that. 2m over that. That is what I'm having. So I want it to look like the one which they are having. So what operation am I going to make that will make me have that? Which means I multiply both numerator and denominator by 2. So if you are here, you want to make it look the same. You are going to multiply both numerator and denominator. Once you are here now, you multiply both the numerator and the denominator by 2, which means this is the same as saying the integral from x1 to x2 under the square root sign. This is 4m. I multiply by 2, and you also multiply the denominator times 2, which means 2 bracket e minus v of x minus v of x. So which means 34 is the one that is going to come outside the integral. After you've manipulated, the 4 will come outside the integral. So it will be outside the integral. Then instead of it being 4m, it's going to be only m because the 4 we have taken outside the integral. Square root of 4 is 2. This is the square root of 4 is 2. Now outside the integral. What is left only is m, which is this one. What is only left is that m. The 4 took it outside the integral, the square root sign becomes 2. E, we change it to v of x2. That was previously our e. So we have shown that first part which you are supposed to show. So now we are going to the second part. In particular, if that v is given by that equation. So already now we have show that the period for the oscillation amplitude A is given by that. So now we are using that equation that you are already having. Show that time is equals to that. So that's where we are starting from. We are starting from the equation that we are given. So the reason, even if you got it wrong, if you fail to prove, you can still answer the second equation. So v of x is given by this, where amplitude is A. So the turning points where the amplitude is A, we are referring to positive A and negative A, which is down. So that E is equals to VA. That energy E, it is V as a function of A. So which means VA, we are replacing, where there is X, you replace with A. Where there is X, you replace with on the original equation. So that is the E. Where there is X, you replace with A. Are you seeing it there? Where there is X here, you are replacing with A. Where there is X, you replace with A. Where there is X, you replace with A. Is it clear? Hello?
Hello.
Yes, where there is X from that equation, which was given. This equation was already given, that one for V of X. Was already given, that equation for V of X. This is the equation, it was given. So we are saying on this equation, where there is X, you replace with A. Where there is X, you replace with A. Where there is X, you replace with A.
Mm.
X, you replace with A. That's what we did. Then once you have replaced, now we are saying E minus V of X. So E is V of A minus V of X. That's what you are just doing. V of A minus V of X. We are subtracting. V of X, V of A minus V of X. Since we said this E is V of A. So now we are subtracting V of A minus V of X. Is equals to that. So where there is X, you still leave it like that. So the constants b, etc. So which means you are just subtracting the constants in the a, the constants in the x, the constants in the b, and the constants in the b is a constant, then a4 minus a x4, a squared minus x squared. Yeah, that's where I'm talking about. We are replacing. Thereafter, you subtract. When you subtract, take out the common factor, which is the constant, half m omega naught squared x minus that, which means you factored out that first. When you factor out that first bracket, which means it will be 1 minus b, difference of squares. So you use your difference of squares. How did they use the difference of squares there? You know, a to the power 4 minus x to the power 4. Difference of squares says a to the power 2 minus x to the power 2. Then you close bracket plus x a to the power 2 plus x to the power 2. That's difference of squares. That's what they did here. So you can still see that a squared minus x squared is a common factor. It's appearing on the first term, which is this one, and it's appearing on the second term, which is that one. So you factor out it, a minus x squared. So this one, if it comes in here, it will be 1 minus. What is left out is this one, a plus a squared, which is this one, which is that. So it was factorization, your knowledge of difference of squares. So tau is equals to 2 root of m over 2 integral. You have been told your limits are plus amplitude plus or minus a. So you replace plus or minus a. Integral of dx e minus v of x. You put your values. So that when you take out the constants outside, you take the constants outside. Why are we having a 2? Why are we having a 2? We are having a 4 omega. Where is the 4 omega coming from? Where is the 4 omega coming from? If I'm to ask you this one, where is the 4 coming from? Maifi? Hello? Maifi? Are you still there?
It's not here.
There is who? Clementine? Hello?
Yes. Abe.
So you are the one attending for Maifi now.
I don't know what happened. Maybe it's her network, as she said.
So now you are the one who joined Maifi goes. All right, let's finalize that one. The time is almost up for that one. So we are saying, where is the 4 coming from, Clementine? Hello.
Hello.
Where is the 4 coming from?
Is it when you want to put the 2 inside?
No. We are saying square root of m over 2. Square root of m over 2. Now we are replacing those values which we are having. E minus v of x, we have found that e minus v of x, I must replace with those values which are half m omega naught half m omega naught squared under the square root sign multiplied by a squared minus x squared. So this is my e minus v of x. It's e minus v of x, this one, which is this one as well, which is this one. And remember, this is under the square root sign, which means the square root of this. Let me see. The square root of what is under the square root sign. That's what we are saying. So it's the square root of that. And also, it's not just ending there. We are saying it's 1 over the square root. So it's 1 over the square root. 1 over the square root. So if it's 1 over the square root of that, which is this which I've just highlighted now under the square root sign, this one. It's not just a square root, but it's 1 over. So if I'm to ask you what is 1 divided by a half? 1 divided by half. What is 1 divided by half? 1 divided by half. What is the answer? It's 2. It's 2. It's 2. Dividing 1 by a half is 2. Just the inverse. So that's what happened. So we are integrating from minus a to a. And there is a 2. If it's minus a to a, we are having 2 like this. We are integrating something from minus a to a. And what are you integrating? We are integrating 2 minus a to a, which is the same, which means when we say the square root, 1 over the square root, we said that one, it will be 2 under the square root of 2. Square root of 2. Then what is under the square root? If we want to integrate from 0 to a, remember this one, these are symmetric. When something is symmetric, I told integrate from minus a to a. Symmetric is the same as integrating from 0 to a. Then you double the integral. So where we are now, the physics part is done. What's left is the mathematics part. So if your maths is very good, we are going to integrate it very nicely without any difficulty, because the physics part was for us to solve for that e minus x, e minus v of x. And we found that e minus v of x, it's half m omega naught a squared minus x squared bracket 1 minus b a squared plus x squared. So what is the square root of that? So that is our question. What is the square root of that? So the square root of that, it will give us is, what is the square root of m? What is the square root of m? If I'm to ask you, what is the square root of m? Square root of m. Because we are not having an m. 2 square root of m, we are not having it. So what is the square root of m? If I am to ask that square root of m. We are here on the integral, where we are supposed to show so that we can reach where we are supposed to show that that is given by that. Clementine? We're already there. We are just left with just 2 steps, then we will conclude. We are already here, isn't it? So we are saying from our integral, it's minus a to a, which is this one. It's minus a to a. So I said, if it's minus a to a, that integral, already we have evaluated what is e. What is e, which was v of a, sorry, v of a minus v of x, which was the same as e minus v of x, which was under the square root of sign. So e minus v of x, that's where we found this value. This is our e minus v of x, e minus v of x. We found that, which is under the square root sign, which is under the square root sign. This one, under the square root sign. Can you see where we put the square root sign here? This one. This one was the e minus v of x, which is this one. So once you find that, you want it under the square root sign. So that's what I said. If it's under the square root sign, this is the same as square root of. Yeah, it's when you are replacing it here. What are you going to replace? So which means I come here and saying from that step, which you are already having, you set up. So this tile which I'm looking for is equals to, you set up your integral. Your integral, it's saying all right. Which is correct. So there you are just replacing like this. So it's the root of 2 multiplied by that. So if you want to put it under the square root sign, 34 under the square root sign, if it's inside, it's 4m. That 4 is going to be 4m under the square root sign. So in other words, we are just saying the integral. In this, we want to replace the integral of minus a to a. That is the integral minus a to a of what? Of square root. Square root. Yeah, correct. Square root of 4m under the square root sign. That 2, when you put it under the square root sign, it's 4m over 2. 4m over 2. Then you are also multiplying it by 1 over square root. But already it's under the square root sign, so there's no need for us to put a square root sign again. 1 over e, because it's already under the square root sign. 1 over e minus v of x. Minus v of x, like that. Then you don't forget your dx. That's what you're integrating. But we found that e minus v of x is this one, which is under the square root, which I'm showing you now. Our e minus vx, which is under the square root sign there. So what is this which is under the square root sign? I'm going to replace by half m omega squared, everything like that. So when you put this, where it's given half m omega squared, etc., under here, which means what are you going to get? If it's half, the denominator, which means the m and the m, this m, which is on the numerator, this m, which is on the numerator, it will cancel with this m on the denominator. Remember, this one is under the denominator. That's the denominator. Then we are having a 2. This 2 will cancel with these 2, the 4 on top, which becomes a 2. And then, because there is divide by half is the same as multiplying by what?
By 2.
Yes, by 2. Yes, this divide by half. Remember, it's on the denominator, same as multiplying by 2. So that 2, which is on the denominator, it has come on the numerator now, times 2. And already we are having times 2 on top, 2 there. So there is a 4 now under the square root sign. So which means this half is now gone. This half is gone. And everything under the square root sign is now a 4. Which means that 2 and that 2, it gives us a 4 under the square root sign, which is now a 4. And here, our answer here outside, there was a 2. That's where this 2 is coming from. When I take that 4 under the square root sign, it becomes a what?
2.
Yes, so I've shown you where that 2 is coming from. Then what's left is for you to see omega squared is under the denominator. And what is the square root of omega squared? It's omega naught squared. Square root of omega naught squared is just omega naught. This is the omega naught, which is under the square, which is now outside the integral because it's a constant. Because when it was inside, it was omega squared. Then the other things that are left, the mass I've shown you how they are cancelling. Then now we are just taking all the brackets as they are. A squared minus x squared. As it is, you are just putting it back as it is. You are not changing anything. Because everything was just under the big square root. So they are just telling us, since it is 1 over, we know that the square root of 1 over the square root of the rest. So they just manipulated. Square root of 1 is just 1. Then dx. So everything is just under the square root like that. So I will share this PDF so that you revise before class, because it won't be moving very fast because people will be seeing it for the first time. So let me share. How come you decided now to attend the class? You were doubting that you are going to write or what? What happened? You were doubting if you are going to qualify?
No, I knew that I've qualified. Just that I did not pay for this.
So what's the plan now?
Pay next month.
When are you going to pay?
Next month. And then there's like 4. I'm writing on the 4th and the 7th. And how we're gonna continue?
All right. So I will hear from you. I forwarded it now, the document, so that you go through all the questions. I forwarded on the group.
Okay.
Forwarded it on the group. So go through. I think I forwarded the wrong one. Let me send this one. All right. Or go through it so that tomorrow we are on track.
Okay.
Yeah, let's go through it. We'll stop here for now.